Hello and welcome back to Tracking Trends. We are back after a gap. I'm sure you missed us. Today we have a very interesting topic. As we speak, as North India was grappling with scorching heat, the country's northeastern states have been pounded by rains. They're underwater. The Sunday morning headlines said as many as 32 have been feared dead. Across Northeast, landslides have been reported. Villages have gone underwater. Monsoon came a week earlier, and a lot of people were clearly unprepared for it, while a lot of people rejoiced it. But what comes out of all of these things is that extreme weather events have they come to be the new norm. To discuss this and several other things related to monsoon and what to expect from the monsoon season that's already underway, we have today with us India's top weatherman, Dr. Mrutyunjay Mohapatra, who heads the country's weather department, India Meteorological Department. He's the Director General there. Dr. Mahapatra is a PhD holder in physics. He is also India's permanent representative to the World Meteorological Society. More than that, very recently, he was awarded the Outstanding Service Award from the American Meteorological Society for enhancing tropical cyclone predictions and warning systems in the Indian Ocean through his exceptional leadership and services. Congratulations once again, Dr. Mahapatra, for the award. And thank you for
Thank
being here,
you.
taking time out on a Sunday. Now, let's dive straight into the topic today. What is it? What is happening? Delhi, NCR, it's raining 30 degrees outside in the month of May, June, unexpected, never seen before. Northeast is underwater. What's going on?
Thank you. Yes, you are right. When you find that towards the end of May, there has been very active monsoon conditions with early onset and advance of monsoon over the country, especially along the west coast, including Kerala, Karnataka, Maharashtra, Goa, and Mumbai city. And also there has been highly intense rainfall activity over the northeastern states. And this rainfall activity has been disastrous, leading to loss of lives, especially in the northeastern states. At the same time, there has been temperature shooting up above 40 degrees Celsius in parts of northwest India. And this temperature also has been disrupted due to the thunderstorm activity in different intervals. So as a result, if you look at the month of May, it has been quite pleasant for the country, with heat wave conditions almost absent in the eastern India and being limited only to northwest India, that is Rajasthan and parts of Gujarat, Punjab and Haryana. The advance of monsoon has been about 8 days before the normal date over Kerala, and about 16 days over Maharashtra, and about 10 days over the northeastern states. This has been possible because of two low pressure systems developing over the Arabian Sea, one and the Bay of Bengal. The Arabian Sea low pressure system became a depression and it hit Maharashtra coast near Ratnagiri, and as a result, it amplified the monsoon current over the Arabian Sea and South Peninsula. And within 2 to 3 days after the advance of monsoon on 26th of May over Kerala, it advanced up to Mumbai by 28th May. Similarly, over northeastern states, it has been triggered by another depression, which became a deep depression formed over Bay of Bengal, and it moved towards northeastern states, crossing West Bengal coast and entering Bangladesh. It caused rainfall activity starting from Odisha to West Bengal, and especially over northeastern states. There has been, you can say, the record-breaking rainfall. Sometimes in Silchar today, there has been 41 centimeter rainfall in the past 24 hours. As a result, there has been widespread flooding, as we predicted. There has been landslides also in different parts, leading to loss of lives and properties. So these are the part of the variability of the monsoon, which shows large-scale intra-seasonal variability, that is variation within the season itself, and also the interannual variability, that's variability from year to year. As a result,
Variability from
year to year,
year to year.
there are year-to-year variability, and also the within the season variability from day to day. So this year, if you just look at while the monsoon onset and advance in the first stage has been quite good, giving lot of amount of rainfall activity over the country in South India and Eastern India, and especially northeastern states, it has been also disastrous in terms of causing the landslides and floods, etc., including the urban areas like Mumbai and Guwahati and other cities in northeastern states. As far as yes, please.
No, let me just pause you there. Just I want to understand northeastern states for the last 4 years they have seen deficient rainfall. Deficient in the sense rainfall has been below the historical average. And suddenly this year, you see monsoon advances at a rather rapid pace, reaches there well before its arrival, usual arrival date, and it's rather heavy. I mean, Guwahati got 111 millimeter of rain in 24 hours. That's unprecedented at this point in time. What is explaining that?
You are right. During the advanced phase of monsoon over northeastern states, almost every year we get heavy rainfall activity. If you remember last year, also there was flood, including Guwahati city, but not the entire northeastern states. But this year, during this onset phase, it has been more devastating because of the fact that the advance of monsoon northeastern state has been associated with a deep depression. This deep depression during monsoon season is just nothing but a rain-bearing weather event. It gives copious amount of rainfall. Even without closing your eye, a forecaster can issue the extremely heavy rainfall activity when a depression during monsoon season crosses in a particular coast. So that is the reason uh, why we have got this type of rainfall activity. It is because of the region's characteristics. We have got the eastern Himalayas along the Arunachal Pradesh. We have got Garo Khasi Jaintia Hills along the Meghalaya. So whenever the monsoon depression or the low pressure system moves over the region, southerly winds move from Bay of Bengal with greater strength towards these hill ranges. And these hill ranges lead to uplifting of the moist air and hence causes extremely heavy rainfall activity. You can just imagine within distance of about 3 kilometers, the height of the Garakasi Jaintia hills can go up to 3 to 4 kilometers. So that is the type of orographic uplifting of the moist air. And as a result, we have got the Monsoon Ram or Cherrapunji as the rainiest place of the world. And June is one of the most intense rainfall month for the northeastern states.
Now let's move to where we live, the Delhi NCR region, the northern region, not the northwest. Let's stay focused on this part. I mean, I read in today's papers that uh, this has been the wettest May for Delhi since 1950. There has never been a May where it has rained so many days, and also there are data that have been reported today, which shows that the number of dry days in the month of May have been steadily coming down. Now, is this a trend that we are likely to see take hold in time to come, which means May, June won't stay as wretched as they have been in the past for people who live in Delhi NCR?
Yeah, before I respond to Delhi, I just want to add something about northeastern states. You told correctly that last 3 4 years, if you just look at the total amount of rainfall in the season over northeastern India has been below normal or deficient. If you take long-term data also, recent 30 years or so, there is a decreasing trend in rainfall activity over northeastern states. That means the seasonal rainfall activity, total amount of rainfall during June to September. But that does not mean that there is no flood event or extreme heavy rainfall event that occurs and being maximum in the month of June followed by the July. Now, this could be attributed to the impact of the climate change. When we have increasing rainfall activity over the increasing rainfall activity over the western part of the country, like Saurashtra, Kutch, Rajasthan, there is decreasing rainfall activity over the northeastern states and adjoining West Bengal, Bihar, Jharkhand, and to some extent eastern UP. This type of bipolar behavior is emerging in the recent years in terms of the distribution of rainfall. But however, total amount of rainfall for the country as a whole remains same. It is not showing any long-term trends, and it is not decreasing. That is a good news. Now I will come towards the Delhi. Yes, you are right. This month of May has been quite rare in nature, not only for Delhi but also for the entire country. The rainfall has been quite excess, and while the monsoon rainfall contributed to excessive behavior of the rainfall in South India and northeastern states, the frequency of the western disturbances caused very good rainfall activity over northwest India and adjoining central India. Usually, the frequency of western disturbances which affect northwest India and central India are maximum in the month of December to March. Maximum frequency is 5 to 7 in the month of January, February, followed by the December. In the month of May, very hardly we get western disturbances which cause rainfall activity over plains of northwest India and central India. But this year, there has been very frequently and consecutively development of western disturbances affecting the northwest and central India. These western disturbances are the weather systems which develop over Mediterranean Sea, Caspian Sea, and they move eastwards across, say, Iran, Afghanistan, Pakistan, and they affect the northwest India. When they reach northwest India,
They're
in the
called westerlies, right? They're called westerlies.
westerlies. They strengthen westerlies and they usually move to the north of Indian latitude so that their impact gets minimum. Hardly one or two systems affect northwest India. But if they extend towards south, then these westerlies can bring moisture from the Arabian Sea, and sometimes the Bay of Bengal moisture can add up, and that has happened this year. So, for the occurrence of thunderstorm, you need intense heating. Usually, it happens in the month of May. Temperature
Mhm.
goes beyond 40 degrees Celsius. You need moisture, which is happening because of this southward penetrating western disturbances. Moisture is supplied from Bay of Bengal and Arabian Sea. Then we need instability in the atmosphere that is there because of the heating. And fourth one is the trigger. This western disturbance is triggering this type of activity. As a result, frequency of thunderstorm has been quite high this year. And when there is a thunderstorm, it leads to rainfall activity, lightning, hailstorm sometimes, and the strong and squally winds. And almost in every event, we are finding wind speed exceeding 60 kilometers per hour in
Mhm.
thunderstorms. And it leads to fall in temperature for the next 2 to 3 days. And
Mhm.
hence, the month of May has been quite, you can say, normal or below normal in terms of the temperature.
So,
But when you consider the impact of climate change,
hmm,
the climate change leads to rise in temperature. Uh, there are rising temperatures in the country, in the pre-monsoon season, that is March, April, May. But that trend varies from place to place. For example, if you just look at the trend over Delhi, we find that there is no trend in past 30 years. But if you compare previous 30 years and recent 30 years, certainly there is increasing trend. But at the same time, because of this rising temperature over the region, 1 degree Celsius rise in temperature leads to 7% increase in relative humidity. So relative humidity in the atmosphere is increasing, and this increased humidity supports the thunderstorm activity. Next one is that as per the impact of the climate change, the temperature is not increasing across the atmosphere. It is increasing the lower part of atmosphere, say up to height of 3 to 4 kilometers. But temperature is falling at a height of say 5 to 10 kilometers. That is middle and upper troposphere. So just imagine the temperature rising in the lower troposphere and temperature is falling in the upper troposphere. So therefore, difference of temperature, as it is earlier between lower troposphere and upper troposphere, now it is increasing. There is a large difference in temperature of lower troposphere and upper troposphere. In a layman language, you can understand like that, but in little technically, we say atmosphere has become more unstable.
Yeah.
So third criteria required for thunderstorm is the more unstable atmosphere. So therefore, all these environmental changes are contributing towards increase in frequency and intensity of thunderstorms and hence lightning, which is a fact.
You
So
you 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 have explained it so well for the layman. No, carry on. You are going to say something.
so while telling all these things, this is a larger perspective. When you look at the broader perspective, for example, uh, Delhi this year, yes, because of all these favorable factors, the number of thunderstorms have been quite higher, temperature has been less. Then we analyzed whether it happened because of the impact of the climate change. We found that temperature has not increased over Delhi. So therefore, you cannot directly attribute towards the global warming, towards the warming over Delhi, but could be impact of the global warming, but not directly caused by the rise in temperature over Delhi. The environment should be sustainable and should be favorable for occurrence of thunderstorm, but it does not mean that the particular location should have that type of environment. But however, the impact of climate change is visible in terms of the humidity. Humidity has increased, leading to the more frequent and more probable thunderstorm activity. The next one which contributes to the activity is the urban heat island effect. Because of the increase in concrete structures, decrease in green cover, decrease in water bodies, the environment becomes more favorable for heating. Say, for example, if we take the city temperature, say in Connaught Place, and you go and measure temperature outskirts of Delhi, say in far away in Greater Noida or somewhere, you will find that there will be a difference of 4 to 5 degrees Celsius. The city center is warmer than the outside by about 4 to 5 degrees Celsius. And this warming can vary from place to place depending upon the marketplaces, depending upon the population density, depending upon the concrete structure density, and depending upon the forest cover and others. Okay. So there will therefore small islands of heat. Therefore, the term is urban heat island effect. And because of this urban heatland effect, whenever, for example, there is a western disturbance moving from west to east, the strong westerly, when they come to Delhi, they will encounter the tall buildings and hence they will converge. And this convergence near the Delhi will lead to uplifting of the air mass and hence it will lead to thunderstorms and the rainfall. So the frequency of thunderstorm rainfall in a city center will be higher as compared to the rural neighborhood. And this is a fact, it is proved in different cities across the globe. So not only that, it also leads to uh, wind convergence, moisture convergence, and heating, and all these factors are contributing towards the increase in rainfall activity and thunderstorm activity in a city.
So, what you're saying, in essence, is India's weather is no longer what it used to be for all these years. It's changed. It's changing as we speak, and there is a greater degree of unpredictability. There's a greater degree of instability in the way our weather systems now move. Uh, and I think, as I posed the question in the beginning, are extreme events, weather events, have come to be the new norm. So, from what you are saying, it looks like yes, they are. And in which case, my next question there follows from there, which means we have to now be doing a lot on the weather prediction front, in terms of building prediction models, forecasting models, in terms of our weather prediction infrastructure. And you are the man who is at the hem of all these things. Now, how good are our weather prediction systems now? To what extent they can capture the need to predict all these varied weather events with accuracy and in time?
Yeah, thank you very much. You have correctly told that the predictability of weather has reduced. That we have proved scientifically because of this increase in extreme behavior, changing climate pattern. There is a direct threat to the predictability of the various types of extreme weather events. So, for example, taking the occurrence of heavy rainfall, it is proved that due to the impact of the climate change, the predictability has been halved. In the sense, if I can predict the occurrence of heavy rainfall in a particular district, say 3 days in advance in normal situation, because of this changed situation, I can predict only 1.5 day in advance. So lead period of the prediction decreases. Number one. Number two is that because of this mechanism, what I explained in larger scale and also in urban scale, there could be small scale development of the extreme weather events. Like there could be localized heat wave events within a city, or there could be localized thunderstorm events. There could be localized heavy rainfall events. Say, for example, it might be raining in one part of Delhi and it might not be raining in other part of Delhi. There could be heavy rainfall causing 10 centimeter in one part, and there could be only 1 centimeter, 2 centimeter in some other part. So this type of behavior um, warrants certain interventions. The initially model whatever we utilized, it has got a capability of 27 kilometer. That means every 27 kilometer you can predict the rainfall or temperature, pressure, winds, etc. So when we understood that there is a need for addressing these localized extreme weather events, so we introduced from time to time the models which can go up to that scale so that it can predicts in a scale of say once in 10 kilometers or 15 kilometers. So while doing that, in 2018, we introduced a global model which had the resolution of 12 kilometers. So that every 12 kilometers you can provide a forecast. And accordingly, we started providing district level forecast and block level forecast.
These are
Now,
dynamic forecasting, right?
dynamic forecasting. But a model is nothing but a set of mathematical equations which are solved with the help of a high performance computing system. These are all nonlinear mathematical equations. Therefore, they are highly dependent upon the initial status of ocean and atmosphere. If you can observe correctly the initial status of ocean and atmosphere, then you can correctly predict the evolution of the atmosphere and hence the evolution of the weather systems. So therefore, globally people try to augment the observation systems. So therefore, the initial, uh, therefore, while taking off the challenge to climate changing behavior, we address towards augmenting our observational systems. We thought that we should take off more satellites and deploy the radars, automated weather stations. Earlier, we have got only 1 in 110 kilometers, one observatories. Now you can find out one observatory in every 25 kilometers because of the increase in automated stations, etc. Till I will say 2014, we have got only 24 WZ radars. Now we've got around 45 WZ radars across the country. Earlier, we have got only one satellite providing forecast every hour. Now we have got two satellites providing not only it does be forecast, satellites observations every 15 minutes. Then, of course, we have got additional satellites, that is polar orbiting satellites, and satellites providing the ocean winds over the different ocean basins. So, by the way, I'll tell you, there has been multiple times increase in the quantity of the weather observations, utilizing directly direct observational instruments and also remotely sensed instruments like radars and satellites. Radar is more useful because the resolution of radar is 350 meters. That means every 350 meters, radar can detect the reflectivity of the cloud and hence the behavior of the cloud. And also, radar provides the internal property of the cloud, whereas satellite provides only the image of the cloud and resolution is 4 kilometers. So, if you want to really predict the very location specific extreme weather events, you need augmentation of radar. So that was understood. So accordingly, we have come up to around 45. But target is that we should have 126 radars in the country. In that way, we are working already. Supply order is in place for 34 radars. So I'm sure by the end of 26 or beginning of 27, we will have 74 radars in the country. And thereafter, next 1 or 2 years, we'll have 126 radars. So once you've got observational data, then it needs to be processed. So you need a high performance computing system. We started with only 1 petaflop machine long back, I think 10 years before. Then in 2018, we take off 6.8 petaflop machine. This year we have taken off another 20. So now we have total about 28 petaflop machine. 1 petaflop means it is 1 into 10 to the power 15 floating point operations per second. In 1 second, it can carry out mathematical operations 10 to the power 15 times into 28. So this enables us, with observational data taken in the morning 5:30, we get a forecast up to 10 days by around 10:30. Similarly, in the evening, observation 5:30 provides forecast by about 10:30. Not only that, we introduced a seamless weather forecasting system by giving a seasonal forecast from the beginning of the season, then following it with the monthly forecast for the next month, then week-wise forecast every Thursday for next 4 weeks, followed by daily forecast for the next 7 days, and then every day we have a nowcast, that is very short range forecast, every 3 hours, valid for next 3 hours. So this addresses the requirement of a basic forecasting infrastructure based on the augmented observational and computing system. Not only that, also we have augmented the communication, data communication. There are various latest communication tools and technology which are being utilized, which are at par with the other international centers. Once you get all these informations, a forecaster also needs a decision support system. He cannot take a decision when there is a lot of information. About 300 GB data is being processed every 3 hours. So it is very difficult to take a decision without an objective digital platform. So India Meteorological Department has come up with indigenous digital support system, decision support system inbuilt within IMD, which has the capability to compare, comprehend, analyze all types of observational data and also the various models data. So you'll be happy to know that every day in the morning and evening, we examine about 7 numerical weather prediction models which are run within the country and around 3 to 4 numerical prediction models which are run globally. You may ask why so many? Because just like doctors differ, the models also differ from each other depending upon their characteristics. So a consensus forecast is generated utilizing decision support system, which is objective in nature. But while communicating to the people, this objective forecast generated by decision support system is converted automatically to a layman language, which is called as public weather service. So all these developments, which I discussed now, has resulted in increase in forecast accuracy by 40 to 50% and reaching out to the last mile in terms of har har mausam Har Ghar Mausam. Target is that early warning for all, that means early warning should reach each and every household in the country. So towards this direction, we are marching forward, irrespective of the threat from the climate change. While climate change limits the predictability and accuracy, forecast accuracy has increased by 40 to 50%. The answer is that we can fight with the adverse impact of climate change if we can intervene with required technological interventions, and we can sharpen our standard operation procedure addressing the requirement and the forecast needs of each and every person. We have to deploy the modeling system which will cater to each and every sector. The requirement of agriculture is not same as the requirement of disaster risk reduction, or the requirement of fisherman, or the requirement of a businessman. So therefore, these customized modeling systems are being introduced, and forecasts are tuned as per their requirement. One more step also needed, taking into consideration the impact of climate change, that the impact-based forecast and risk-based warning. You cannot provide forecast simply. You tell what the weather will do tomorrow instead of simply speaking what the weather will be tomorrow. So this concept we introduced in 2019, and now for all the severe weather events, the impact-based forecast and risk-based warning is being provided. In case of cyclone, is it the village level impact assessment, risk assessment? In case of heavy rainfall, at present we have got district level assessment of risk and impact and vulnerability, and for heat wave and cold waves, etc. Thunderstorms. So we have to go further. We have to improve this impact-based forecast, risk-based warning, not only by improving the weather forecast, as we discussed. As you go further, there will be further impact of climate change, and hence you have to go for more localized weather observations and forecasting system. But also you have to assess the hazard. The knowledge risk has to be generated based on the past data. You have to go for geospatial mapping. We should have digital elevation modeling, digital surface modeling, and we should have the socio-economic indicators. All the data, for example, in a city, you should have data on drainage systems, data on the buildings, roads, bridges, culverts, forestry, water bodies, and so many, so that you can have a superimposition of the weather hazards with the secondary hazards, geospatial informations, socio-economic indicators, and hence you can have a real-time risk in a very granular manner to fulfill that target,
No,
that the information will be available in the household.
that's very encouraging to hear. So you need to spend more on radars. You need to spend more on computational systems. Perhaps you need more dedicated satellites, and I guess you have the money for that now because there is Mission Monsoon that was announced recently. You got 2,000 crore under that head. Is that enough? Is that money enough?
Yeah, when we prepared the mission Mosam, actually we targeted more. So there is a financial cycle in the country, just like 15th Finance Commission, then 16th Finance Commission. So Finance Commission period is ending in 2026. So initially, therefore, we targeted for 2 years, that is 25, 26. And accordingly, the mission Mosam has been for 2,000 crores, but in an extended manner, perhaps we need around 20,000 crores, and accordingly, the plan is being put off because
So you need
the
more money. You need
more
more
money,
money.
more investment. The target is that by 2047, when we reach by completing 100 years of our independence, the India should have a weather forecasting system in which you can ensure the smart actions, the smart climate actions, and weather readiness actions. Each and every farmer, each and every fisherman, each and every household will mainstream his or her activity utilizing weather and climate informations. Not
No,
only it will
20,
ensure zero loss of life and property, but also it can improve the socio-economic conditions of the country.
but you see, 2047 is very long term. In the long term, we are all dead. The point is, up until now, IMD has gone wrong nearly almost on half of its long term forecasts. And as of now, yes, the forecasting systems have improved. There is a lot more capability now with you, but the reality still is, more often than not, we have had Australians predicting our weather better than us. They have much better systems. More often than not, we have depended on certain forecasts by the Americans, and I'm pretty sure the Chinese also must be knowing better about the Indian weather in many ways. The point I'm trying to make is that we the challenges we face are there before us now. Uh, but the plans that you spelled out are something that will prepare us for them at a future date. So, in the interim, how do you think, because we are a country where nearly more than 60% of people depend on agriculture. Now, for instance, when this time monsoon has come 8 days early, in many parts 10 days early, things are changing, and farmers can't cope with it. They can't keep changing from year to year. They don't get so much of institutional support. So what is it that IMD can do uh, to facilitate a more responsive intervention when weather changes in such drastic fashion, keeping in mind the interests of people who are most dependent on it, primarily our agricultural sector, and primarily people who are more vulnerable to sudden flooding, or sudden heat wave?
Yeah.
What is it?
So thank you. Yeah. Thank you very much for your concern. But I do not agree completely with your assessment of the weather forecast. I just want to mention here that uh, the weather forecast of cyclones, take an example, you can find in recent times people dying in USA, not in India.
No,
You
you have
can.
done. It shows that there is an award for you. It shows your personal contribution
Yeah,
there.
that's
Yes, on
right.
cyclones we have. No,
We have compared. Similarly, we have compared the heavy rainfall forecast accuracy in India and USA. Our forecast accuracy is continuously improving, and there is almost stabilized. And there is huge difference between the forecast accuracy of USA and India if you consider the heavy rainfall. Like that, these are the comparison irrespective of the type of weather system which affect the different countries. For example, India is a tropical country. Here, the weathers are more variable as compared to the USA, because USA is a mid latitude and extratropical country where the weather occurs mainly because of the warm fronts and cold fronts, which is not triggered by the convection. Whereas in India, the weather is triggered by the heating and hence the convection. And this convective nature is very random, very short scale in life, and also very much localized sometimes. Therefore, these are the predictability challenges. So, therefore, sometimes it becomes difficult to compare. Therefore, I gave the comparison of the system, which is large scale nature, which affects the southern parts of USA. That is the cyclones I told you, and also heavy rainfall comparison I gave, but which may not be correct because the USA environment is different, but still then we are performing better. But telling all these things, the challenge is that we should target the future needs of our farmers, as you told, our fishermen, our poor people, and our socio-economic activities. So towards that direction, already, as I explained, you need a good infrastructure. We are working towards that. And also, you need a system where you can cater to a large strata of the society. You can find here in the same country, there are farmers which are highly qualified, say in Kerala, and there are farmers who have got relatively lack of capacity to absorb the knowledge. So, within this diverse behavior, also the weather forecasting has to evolve, and it has to cater to the requirement of the small farmers, to the large farmers, and differently qualified farmers and fishermen also. So towards the direction, what we do actually, we have to go for inclusive approach for this purpose, and we are tying up directly with the farmers for this purpose through Ministry of Agriculture, State Agriculture Department, Even for example, we have gone up for developing the WhatsApp group with target is at least 5 farmers in a particular village should be connected with India Meteorological Department. And the information should be provided as they want, and it should be in local language. And also we come up with another scheme that whatever mobile app or information is generated at the state level, that should include the weather and climate information so that it reaches to each and every person in that particular. 20 states have come up so far. They are taking the information from India Meteorological Department, and even states were working towards that so that their information should have weather and climate information on daily basis. The third approach what we've taken actually, the Ministry of Panchayati Raj, we have gone for. So whatever system they have got to communicate information that is being utilized for weather communications, every panchayat secretary, every ward member, every sarpanch at present gets the weather information for further communication to the people. Similarly, we have come up with the Ministry of Rural Development like Pasu Sakhi, Krishi Sakhi, that is Krushi Sakhi. Then one is for agriculture, other is for the animal husbandry. So, and this is also another approach towards women empowerment. The information on weather through ministerial development will be reaching towards all Krishi Sakhis and Pasu Sakhis across the country. Not only that, we have gone for public-private partnership through which the information is being reaching out. Say, for example, Reliance Foundation, MS Swaminathan Foundations, and many more. They are also reaching out to the farmers at their village level. Recently, it has been shown in a city case. I'm giving an example. The Rickshawala Association, Street Vendors Association, they have come up. So, for example, heat wave in Delhi, they came up and we started this service. We are giving the forecast. They are writing in their own language, putting up in the center of this market, and people are being educated, people are being informed every day. So what action they have to take in case of temperature reaching say more than 40 degrees Celsius, or there is a forecast for the thunderstorms. So challenge is huge. So these are some of the steps to reach out to the last mile and the last strata of the society, apart from the other large scale approaches.
Thank you for explaining all of this. Now we have gone well beyond the time we had allotted ourselves, but I wanted to ask you a quick couple of things about your predictions for this monsoon season, and perhaps in the next 2 to 3 minutes we will be able to do that. So you have predicted that rainfall will be 106% above the historical average, and you have said that there is 90% probability that that will happen. You're very confident about it?
Yeah, I just want to mention here that the seasonal forecast is having the less predictability. Therefore, many countries do not issue seasonal forecast of rainfall. But India has started seasonal forecast of rainfall in 1878, I think.
Yeah,
We started
from the
somewhere
time
there.
the
Western
Monsoon,
Himalayan front.
yeah.
Yeah. But now, in the recent development is that in 2021, for the first time in the country, we gave a seasonal forecast for entire country. That means now you can find out the seasonal forecast for Odisha, you can find a seasonal forecast for West Bengal or seasonal forecast for Chhattisgarh. It is a spatial map indicating the probability of occurrence of seasonal rainfall as above normal, normal, or below normal. In addition to that, for the country as a whole, as we gave earlier, we have given this year 106% plus minus 4%. Now, while telling so, if you tell in terms of the probability of occurrence of heavy rain, probability of occurrence of the above normal rainfall this year is 59% against the climatological probability of 33%. So therefore, there is a high probability against the climatological behavior. If you look at this year, there is a high probability that rainfall will be above normal. Normal is defined as plus minus 4% of the long period average. Country gets about 87 centimeter rainfall, plus minus 4, that means 104 to 96% of 87 centimeter is called as normal rainfall. And this year we are expecting 106% of the 87 centimeter. So it can vary from 102% to 110%. With respect to accuracy, I will tell you, yes, I agree that seasonal forecast accuracy was not good. But just let us compare the new system. we introduced this new system, which is a multi-model ensemble system. Earlier, we used only one model, but now we are utilizing the best 5 models available across the globe. Every month, we examine and provide the forecast. For the seasonal forecast, also we did out of 10 to 12 globally available climate forecast models, we consider the best 5. And utilizing that, we are providing this forecast for the entire country and the different parts of the country. Now, out of curiosity, I also compare how was the performance previous years and how is the performance here. We compare the forecast accuracy of seasonal rainfall forecast over the India as a whole in the year 2021 to 2024, 4 years, vis-a-vis the previous 4 years, that is 2017 to 2020. We found that our error was 7.5% in the previous 4 years, and in the recent 4 years, the error is 2.28%. And our model error is plus minus 4%. So what I want to say that error in the past 4 years has been within the model error. It is 2.28 versus model error of 4%. Whereas in the previous 4 years, it was more erroneous. It was 7.5% against the model error of 4%. So I agree with you. Earlier, our forecast accuracy was not so good in terms of seasonal rainfall, but at present, for the past 4 years, it is quite good within the error limit.
Two more questions, and then we'll wrap up. So I'm just going back to, you have predicted in 30 out of the 36 subdivisions, rainfall will be normal or above normal. Does that mean geographically monsoon will be well spread, more equally distributed? Is that what is coming out?
Yeah, if you look at the India map, the forecast rainfall, it shows that there will be uniform distribution of rainfall activity. It's a good sign for the country. Most parts will have normal to above normal rainfall, except northeastern states, Ladakh and adjoining Jammu Kashmir and Himachal Pradesh, and then some parts of extreme south, that is southern parts of Kerala and southern parts of Tamil Nadu, in some parts of isolated pockets of Rajasthan. So therefore, it guarantees this forecast, if it comes true, it gives that there will be good rainfall activity. But while talking of the meteorological subdivision, this is again a historical decision has been taken this year based on the inputs and suggestions and demands from the public, that for the first time IMD introduced meteorological subdivision level seasonal forecast. First time. So therefore, we should not expect very high accuracy, but we have made a beginning. It will improve further with the validations and further improvement in the modeling system. But it shows, as you told correctly, that there will be good rainfall activity in major part of the meteorological subdivisions, and only 4 subdivisions are showing below normal rainfall activity.
You have explained several complex phenomena, complex science, and complex issues in a very exhaustive and expansive manner. Now, no matter how many machines you build, how many models you devise, you can never predict nature fully. What we can do, however, we can keep enhancing our understanding of nature. So we should be humble enough, therefore, to say that we are trying to understand nature, and there is a science to understanding nature. And I think that's what your department is doing, and that's what we can hope that we can keep getting better at it. Thank you so much for giving time on a day like this. And I hope our audience would richly benefit from this exposition. For our audience, a request: if you have been with us so far, please share the video, subscribe to our channel, and keep coming back. Thank you, Dr. Mahapatra. Thank you for taking over.
Thank you very much.